Plot all of the existing features of the following rational function. If you get a fraction or decimal, then plot as close to the true location as possible. This is one rational function I assumed. First of all, we simplify the possible. Then we rewrite our function. The first step, we are going to find our vertical asymptote. Vertical asymptote is where is the denominator equals to 0. So when x squared minus 16, then we have x equal 4 and x equal minus 4. F of x is undefined when we divide by 0. Let's draft our vertical asymptote on the graph. We have a vertical asymptote at x equal 4, and we have another one, x equal minus 4. That's our step 1. Say if we have a common factor in both numerator and denominator, but in this case, we don't have one, so we don't have a hole here. Now we are gonna resolve the horizontal asymptote. Let's write down our original function. Let's imagine if the y is a very, very, very large number, then you can ignore this part because those numbers are not gonna affect the answer. So the function would be approximately equal to f of x equal to 4x squared divided x squared. In this case, we can see the degree of numerator is the same degree as the denominator. So our horizontal asymptote is y equal to 4. Let's draft on the graph our horizontal asymptote. Then we're going to find our x-intercept, which means y equals 0. And we're going to find our y-intercept, which means x equals 0. So let's see the x-intercept first. We know when denominator is equal to 0, the function is undefined. So we set the numerator equal to 0. Why we have this new numerator? Because we simplified earlier. Then we get the number when y equals 0, x equals 3 over 2, which means 1.5. Our x-intercept on 1.50. Then let us resolve the y-intercept x on 0. So the only thing we need to do is plug x at 0 back to the original function. Simplifying the answer, y is equal to minus 9 divided 16 equal to minus 0.56. So let's draft our graph. If we know our vertical asymptote is at x equal 4 and x at minus 4. Then we draft our horizontal asymptote at y equal 4. Then we point out our x-intercept on 1.5 and 0. And we mark down our y-intercept on 0 and minus 9 divided 16 is at minus 0.56. Then we connect them together and we know we cannot touch the asymptote. So we already can draft it. Cannot touch the asymptote and it's unlimited close to. This would be our final graph looks like for this function.